All right, we are starting investigation 4B today about acceleration. So for the setup, we have our physics track and we have photogate A that's going to be in the same spot every time, and we're moving photogate B down the track. That way we can get the instantaneous speed at each of those points. So the first thing that you need to do is make your predictions about what you think these different graphs would look like. So take a minute to answer A and B. This does not have to be a full graph with a title and everything, but just go ahead and sketch what you think that would look like. All right, now it's time to actually do the experiment. So we're going to be going through each of those trials, getting the time through photogate A, so that's that TA, and then the time from photogate A to B, that's TAB on the data collector. All right, starting our first run down here. We have that car set, so it's exactly on the mark. My first photogate is 10 centimeters away from the start, and then photogate B is 10 centimeters away from A. So we're looking at the time from A. So you have 0.0113. We don't need the time through B. And then we're looking at time from A to B. And I said we don't need time through B, but we'll actually need that for that second experiment. So I'm going to go ahead and take a photo of this every time so I can include that at the end. All right, moving photogate B 10 more centimeters away. So now the distance between A and B is 20 centimeters. Let's go ahead and release the car. The time through A we should see is the same every time, or very close at 0.0113. Again, we don't need the time through B right now. We just need to record the time through A and B, which is 0.169 seconds. We can't test the photogate at 30 centimeters away, so we're going to skip to 40 centimeters away. And go again. Time through A looks a little quicker this time, 0.0112. And time through AB is messed up. Let's try that again. So, is that going to stop it? This will stop. I think I reached through and messed that up. Okay, there we go. So, that time through A is 0.0113 seconds. We're ignoring time through B for right now. And the change in time from A to B, that's 0.285 seconds. All right, so that was 10, 20, we skipped 30, that was 40 centimeters away. Now we're going to 50 centimeters away. And we're going to release again. We get 0.0113 seconds for the time through A, and 0.332 seconds for the time between A and B. All right, we're moving this down another 10 centimeters. And that was the problem last time. There we go. All right, running through this one. We have our time through A, 0.0112 seconds. Again, skipping time through B for now, and we get 0.378 seconds for this one here, which is 60 centimeters. I think we can try one more at 70. So let's go ahead and try that as well. I don't know if you have enough spaces for this on your table or not. I think so. All right, last one. We get 0.0112 seconds for time through A, and the change from A to B, 0.420. All right, now we're completing part 4 where we're doing the position versus time graph for acceleration. So we can use that data. Make sure you're following the directions for how to label those axes. So position is going to go on that y-axis and time will go on the x-axis. So we're doing how does the position change given the time. And then we're going to go through part 5 where we're looking at to see how does the speed change over time. So not just the position, but how does that speed change. So for this one, we do need to collect the time through photogate A, time through photogate B, time between both, and then you are calculating the speed at photogate B. So remember that means you're using the time through photogate B. And what's the distance that you use? Remember that 1 centimeter, and that does not limit your sig figs. It's exactly 1 centimeter. So make sure you're calculating speed with the time through photogate B and 1 centimeter as that distance. When you're done with that, you can go ahead and make your graph for speed versus time. Again, we have time on the x-axis, but now we have speed on the y. Make sure to have your title, labels, and units. Finally, we can go ahead and answer part 6. So did the car accelerate as it traveled down the hill? And then answering the rest of these questions. You can actually find that acceleration of the car as well. And then we're going to also do a prediction. So it says use your speed time graph to predict how much time would elapse for the car to reach a speed of 200 centimeters per second. And use your position versus time graph to predict where on the track the car would reach a speed of 200 centimeters per second. So go ahead and make your predictions. I won't be able to test all of your different positions, but I'll test a couple of them. So hopefully in this next piece, you'll see one that's close to what your prediction was. All right, so I have moved my photogate for the prediction to 42.5 centimeters. Let's go ahead and, oh, there we go. So I'll reset. So at 42.5 centimeters, we have this for our data. Go ahead and take a picture. So test that for your calculations if you guessed somewhere near 42.5. I'm also going to test 45 centimeters away. So let's go ahead and perform the 45 centimeter test. So we have our data here. If this was yours, you can use this. I'm going to do about 47.5 centimeters away. Again, we have our data. And I don't think I have to go to 50, so hopefully your guess was somewhere in between that 40 and 50 centimeters. If not, double check your calculations. Okay, bye.